Hi, this lecture is about the second chapter of Grade 11 OL ICT syllabus. Right, the second chapter is System Development Life Cycle, or else you could also call it Software Development Life Cycle. Okay. Now, system development. Now, what is a system? That's the question, right? According to your book, according to the Grade 11 ICT book, what is a system? It is a set of components working together to achieve a particular task or do a particular task. Okay. Now, look at the examples given there. They have said the school as a system. Okay, what does the school do? Okay, what is the input of a system? Now, that is a bit of a question, right? Now, a system, right? A system has three main components. We already know that, right? A system will have an input, then it will be processed, and then you have output, right? You have these three things. Now, input, process, output. Now, among these three, take the school as a system. Your school, right? School, what are you inputting there? Now, go through your book. The input is students or kids, children, right? Children are the input. Then, what is the process there? They are subjected to learning, right? Learning and a lot of guidance and all. So they are being prepared and mended, right? The school, that's what they do, right? In some places they get a lot of beating also, some students, right? That's a different story. Okay, now the child is admitted to the school, that is the input. The school teaches or makes the learning easier for the kid. So once the child or once the student comes out of the school, the output is a responsible and good citizen to the country, right? So you see, the school is also a system there. Another example, let's take the human body, right? The whole body is a whole system, right? But in the human body, there are many subsystems. Now, the body itself is a system, but in your human body, there are many subsystems working for a specific task. Now, there is this respiratory system. So, you can exchange carbon dioxide and oxygen. And then you have this digestive system for energy, right? You eat your food and then it is transformed to energy, and then you are healthy, right? And your skeletal system for you to stand straight and be healthy, and muscular system to be able to move your hands and joints and all, right? So likewise, there's a lot of subsystems inside your human body, right? Now, in the human body, if you are considering this, let's say, usually we all might have come across a situation like this at school. Now, let's say you're feeling a bit headache at school, right? You're feeling a bit headache, right? Headache. So you're just lying down on your desk, and a teacher comes inside the classroom. So you just pull up your head, and then you see, okay, the teacher has come. You just stand up, and then when everybody sits, you sit down, and then again you go back to lying, right? You just lie down. Now, let's say the teacher is starting to give notes. She's starting to read something, let's say. So, what if you are the only person lying down, and all the other students are attentive to the lesson? Then the teacher would surely notice you, right? So then the teacher might ask you, okay, what's wrong? Why aren't you writing? Right? I'm reading stuff, so you have to write them down. Why aren't you writing? So you're just lifting your head and then saying, I have a headache, sir, a headache, madam, right? So now, what might have been the answer for that by the teacher? Can you guess? Usually, we hear this. What is that? You're not writing with your head, you're writing with your hand, right? Then write. You're not writing with your head. You have to write with your hand. Hand is fine, right? Then go. Now, what would be your reaction to that response from the teacher? You surely know that you cannot write. Why? Because although the pain is in your head, you cannot write. Because the whole system is affected just because a pain is caused on the head. Why? Because it is a subsystem of the whole system. So when a subsystem gets affected, the whole system faces it. Right? Just like that, each and every subsystem in our body helps the other. Right? Now, let's say you got a blockage in your respiratory system. Right? Let's say your nose and mouth is blocked somehow. Now you can't breathe. What would happen to the system? What would happen to the system? The whole system would die, right? The whole system would die. So just like that, each and every subsystem is working together to make a full whole system that works perfectly, right? So that is a system, right? Some components working together to perform a particular task, right? Okay. Now, as I told you, the system has 3 components, and when we are coming into information system, if it is information system, then the input is data process into information. So what is an information system? A system that converts data into information, meaningful information, right? So even you might have heard of a lot of learning management systems, right? These things, they gather data, process it, and turn it into meaningful information. Now, there's been a lot of examples given in your book. Just go through those examples. Now, you might be wondering where these examples are, right? Those examples are available in your grade 10 ICT book, the first chapter. Just go through those things, right? I think there was an example of a fingerprint reader. It's a now in this fingerprint reader, if it is in a workplace or a school, right? A person comes in and then places a fingerprint. So what is the input there? The input is the fingerprint, right? Let's take example fingerprint reader, right? Now in the fingerprint reader, fingerprint, right? Print is the input, and what is the processing going on there? The processing is they are checking whether the fingerprint is available in the system, right? And then if it is available, then by the end of the day you will get the number of hours the particular person has been in that place. Just like that. Just remember this. Information system means converting data into information. That is the concept, right? Okay, there are two types of information systems, right? One is the manual and the other computerized information system. Okay, now what is the difference between these two? What is a manual system? Now, manual means whatever the work, it will be done by a human being, right? Humans will be doing the work of converting data into information. Now, just take an example of this, let's say Cargill's here in Sri Lanka. Cargill's, the supermarket, right? At Cargill's, now most of us have been to Cargill's, right? So there'll be at least 3 or 4 cashiers for the billing. So then just think of this work like the billing process. If each and every cashier doesn't have a computer, just imagine there are 4 cashiers but no computers. What would they have to do? The conventional way. What is the conventional way? Okay, if there are 5 items, okay, checking the item, how much? Okay, right. Writing it down, okay, checking the other item, writing it down, the 5 items, okay, bill, handing over the receipt. How much time will it take? Right, just think of the workload. Now, after each and every day, they have to write down a summary. Okay, how much from sugar, how much from rice, how much from biscuits, how much from tomato, whatever, right? So, how much of those were sold for the day? How much sales, how much profit? Just think of the time that would be allocated for doing all these things. It's going to take a lot of time, right? So, this conventional method now is replaced by computers. Computers, they have barcode readers. There is a point of sales system. So you just show the item to the barcode reader, you just point it. Automatically the price, everything, the details will be displayed on the monitor. You will have to just type in the quantity. So the price will be calculated. Right? So when it is computerized, it has become easier. Right? So this manual and computerized systems have a lot of differences. Now we'll look into those differences now. Okay. Now you can turn out your page number 56 in your textbook, and you can find there's a table differentiating manual systems and computerized systems. Okay, now these 4 are the topics discussed there. I'll tell you about each and every topic. Now, errors. Error means mistakes, right? So, when you're considering human beings, manual systems, there's a possibility of making errors, right? Because humans can make errors because they are humans. They are humans, so they can make errors. Only God doesn't make errors, right? So, error is not a possibility in computers if your input is correct, right? Computers usually don't make mistakes. Computers don't make mistakes, right? So, and humans are prone to making mistakes, right? Humans can make mistakes. That's what errors, right? So, next, efficiency. Efficiency means a computer can work 24 hours a day without getting tired. But can a human work more than 12 hours on the floor? I don't think so, right? Without getting some rest or some boost or some other kind of supplements, a normal human being would face it difficult to work more than 12 hours continuously, right? So now that is the difference between a computer and a human, right? That is why nowadays in many sectors, in many companies, in many industries, they are replacing human beings with robots or computers. Robots, they can work all the time, right? Humans, they slack, right? They slack when they are tired. The work slows down and people are tired, right? So let's say a factory, right, that makes these things, markers, right? Let's say they are making markers. So human beings are there to fill the gap. The markers would be coming on the floor, right? Human beings have to fill this thing and put it inside, then close it. Black color with black color ink, right? Black color marker. Now let's say these people, they are working for more than 8 hours now, right? They are very tired, but the boss is looking and the boss is watching, so you have to work, right? Sometimes they will be working like, okay, right? It will be difficult for humans. So like sometimes they might put it like this. Oh no, wait. So see, it would be a difficult task for humans because humans, they get tired, but computers, they never get tired if the conditions are okay, right? If the computer is placed in a cool area and a clean area, computer will be fine for as long as we want it to be. So computers are efficient. They can work for a long time without getting tired. Next, storage space. Now this differs. You can just take an idea like this. Now just think of your school. In your school, there'll be a file for you, right? Your birth certificate and your school admission documents and all those things will be there with your name written and your index number. You'll have a file. So likewise, for all the students, for each and every student admitted to your school, for all the students in your school, they will have a file, right? With the student's name and index number. Now just think, there's around 3,000 students in your school, right? So there will be 3,000 files, right? There will be 3,000 files for each and every student. What about the students who have left the school and haven't taken their birth certificate back? Still there will be a lot, right? So let's say there's around 4,000 files. Now the school has to store it, right? The school has to store it. So how many racks do you need? How many cupboards do you need to store these things? You'll need a lot of space, right? So this is manual. So manually, if you are storing those things, it takes a lot of storage space. But in the computer, it's just a computer, right? The computer takes only the space once. Say it's a laptop. So the laptop is confined to its size. So the laptop doesn't grow in size, right? When you put files, the laptop doesn't grow, right? When you keep on adding files inside the computer, when you keep on saving, the hard disk space fills up. But still, you can fill more than 1 million files in your hard disk, right? In that particular computer. So this is another advantage of computerized systems. Why? In computers, it takes only a small space to store information. And the next thing is security for your files or information. Now, what is the security do you need? Take a manual system. In a manual system, if you are storing those files in a cupboard, then you'll have to lock it, right? You'll have to lock it with a key, you'll have to use a padlock, right? Fine. So you are locking it with the padlock, and you have it. Take the okay, the next thing is security. Security for your files or information. Now let's take manual system. Manually, when you're storing the files in a cupboard or a rack or something, you'll need to have a lock, right? Lock and a key manually. So what if you are using a computer? In a computer, it is passwords. You have passwords to protect your files. Now you can argue in both directions. Why? Because a lock is breakable, right? If somebody tries to steal the files, then the lock is breakable. Still, passwords are also hackable, right? Still, there are pros and cons, but still, you can think about this. Now, for your files in a manual system, let's say there was a fire. There was a fire in the place, and all the files got burnt. All the files got burnt. How are you going to get it back? Original birth certificates and all. It's a very painful process, right? It's very difficult. Think about the computerized system. Let's say the laptop burns, right? Laptop burns. Now, if you have uploaded your files to a cloud storage, if you have uploaded your files to a cloud drive, no problem. Even if the laptop burns out fully, you can still get all your files back without any problem. Now, these are some differences between manual and computerized systems, but mostly nowadays we prefer computerized systems because they are easy and saves a lot of time and money, right? And even there are trust issues with humans, right? Humans are somewhat not worthy of trust, but computers can be trusted. Why? Because computer doesn't know how to cheat, right? So we cannot trust a human, but we can trust a computer. So computerized information systems are a better option these days, right? Next, we have to look into system development life cycle, right? System development life cycle means developing a whole software. Here we are talking about software development life cycle, right? So software development life cycle means creating a software to solve a particular problem. That is a software, right? We create a software to solve a particular problem, right? We look into SDLC. Now, as I told you, system development life cycle means creating a software, the process of creating a software from the beginning to the release, right? So you have around 6 steps in your book. You can just go through. First, requirement identification. Then you design it. Then you implement it. Then you test it, deploy it, and finally you maintain your product, right? Now these are the 6 steps. Now we'll just go through each and every step. Okay, requirement analysis or requirement gathering, you could say, right? Requirement gathering is the first and the utmost basic step in developing a software, right? When it comes to requirement gathering, it is starting from the person who needs the software. There should be a problem to solve, right? The person who has a problem and he needs a software. So that is when this requirement process comes into play, right? Now, can you think of the daily activities and daily software, daily applications that you are using in your smartphone or in your computers? Now, all of us know about WhatsApp, right? WhatsApp or YouTube. Okay, WhatsApp has solved a particular problem. What is the problem it has solved? Communication. Communicating between two people from anywhere around the globe, right? WhatsApp has enabled us. So, a particular problem has been solved using this computer software or smartphone application, right? Take another example, say YouTube. YouTube, what is the problem it has solved? Entertainment. We have a lot of entertainment, videos and stuff in YouTube. So each and every application has solved a particular problem. If you have a problem, then you need a software. Can it be solved by a software? Then you can start building the software. So the first step is requirement gathering, right? When you are gathering requirements means what a person needs in that software, what a person expects in the software. Let's say you are the customer, so I'm the software developer. Then I'm asking you, what do you need in your software? That is my question. I'm gathering the requirements. Can you understand? I'm gathering the requirements from you. You are the person who needs the software. So I'm asking you, what do you need in the software? What features do you expect in the software? So likewise, there will be a set of questions I'll be asking you to develop the software, right? Okay, so there are several methods of collecting those requirements. There are methods of collecting those requirements. Observation, interview, questionnaire, document sample, prototyping. I'll tell you about each of these things. The first thing, observation. Observation is done by going to the place and observing the business or company. Let's say you are running a supermarket and you need a software for the sales and accountings and all. But if I'm asking you questions, you can't understand. So the best method is, first you go and observe the business. You go and observe the business. So the software team, the software engineer, the business analyst, they go to the place where the business is going on, go to the supermarket, and then we observe, okay, what is going on here? Okay, the cashier is doing those things, okay, the salesman is doing these things, the manager is over there, he's doing those things, right? So likewise, we observe, okay, this is how the business is going on. So how can we put it into a software? How can we make their work easier? So that is observation, right? Interview. Interview is just asking the questions directly with the customer. Okay, if you need a software, you'll have to answer some questions. Okay, now if I'm the software developer or if I'm the software engineer and you're the customer, you're the person who needs the software, then I will interview you. I will ask you some questions. Okay, what do you need in this software? Okay, what are the options you need? Do you need reports and all those things? I'll be asking you a lot of questions and then writing them down, then gather the requirements. That is interview, simply put. Okay. Third method is questionnaires. Questionnaires are a bit, a common method used to gather some data that are confidential. Confidential data gathering. Questionnaires, right? Because sometimes, let's say, now if I'm the software engineer and you are the client and you have a supermarket, you have a lot of workers in your supermarket, I'm visiting the supermarket, right? I'm asking some questions from the salesman in front of you. You're the boss, the salesman is there, I'm asking some questions from the salesman. The salesman wants to tell something, but he's afraid because you're watching, right? So, if he was in private, he might have told me. So just like that, there are certain things that cannot be put out public through words. So, questionnaires give that opportunity, which means questionnaires are a set of questions as a booklet. Questionnaires is a booklet where there are questions. So we hand it over to each and every person in the company. They will fill them and give it back to us as answers. So we will go through those things and then we can gather the requirements, right? That is questionnaire. And document sample collection. This is a crucial part. Now for accountings and all, we have to have an idea about how this company works, how their accountings are done. So for that, to get an idea, we collect a few samples from their company. Okay, give me that file, I'll take it and gather the requirements and I'll return it back. So what do? You collect some samples from the company and then take it to your place, learn the pattern of their company, and then you get the idea of what should be included in the software, right? And finally, prototyping. Prototyping means it is like, okay, after you have done all these things, right? After you have done these steps, if you have an idea, okay, this might be the software this person is expecting. Now you might already have a software similar to what you're asking. Can you understand? Now, I might have a software similar to your requirements. After I have gone through these things, now I get an idea, okay, I have a similar software that suits the requirements of this person. So what I'm doing is, I'll prototype, which means according to your requirements, I'll show you a dummy software. Dummy means it's just an outline. Okay, I have an idea already. Okay, I have an idea about this. Is it okay? Like you're showing him already a software interface, which means it's like you're showing a model to them. Prototyping means showing a model of the requirements that the customer is expecting. So I'm showing you a model. Okay, is your software requirement like this? Do you want it like this, or do you want any changes? Is it okay? Is this software okay? You're showing them a model, right? Now this was a software made for another person, right? Now is this okay? Like this, is this idea okay? Or sometimes you create a prototype for that particular customer. You create a dummy software interface and then you show it to the customer. Okay, do you want it like this? Just an idea, the outline. You put the outline and show a model. So that model is the prototype. Okay, so these methods are used to gather requirements. Okay, before we move on to the second step of designing the solution, designing the software, we have to look into something called feasibility study. Feasibility study means checking whether the system or the proposed system. Now you have gathered the requirements, fine, but you have to check whether the requirements are feasible to make up a software, whether it is possible to build a software according to those requirements. So feasibility study includes three main things, mainly economic feasibility, technical feasibility, and operational feasibility. Operational, okay. Now, what is economic? Economic feasibility focuses on the budget of the customer and then whether it is possible to make or build the whole software within that budget, within that money, the amount of time and money spent on the development process. So we just take the time and money and consider, okay, according to these requirements, it would cost around this much. So the customer is only ready to pay 2 million. For example, the customer is ready to pay 2 million, but the cost of creating the software comes up to 3 million. So it is not possible to build the software with a 2 million budget. So just like that, economic feasibility means checking whether it is possible to build the software with a specific amount of time and money. Next, technical feasibility. Technical feasibility focuses on the software and hardware equipment required by the customer for the software. Now, let's say, take that supermarket example. Now, if the customer is asking you some hardware requirement that is not available in the market, you're just writing them down, but when you are going through the technical feasibility, you identify, okay, there is no such hardware like this that the customer has requested. So it is not possible to go further, right? So likewise, you have to see whether it is possible to build the software using the available software or hardware requirements, right? So that is technical feasibility, checking whether there are hardware equipment or software related to the requirements. Third is operational feasibility. Operational feasibility is getting an idea about whether the developed software will be used fruitfully, whether the customer would be able to use that software properly. Now, for example, if the people working in the supermarket are not so literate about the computers, if they don't know about using computers, then they might face a difficulty in using the software. So that comes under operational feasibility. We have to see, okay, whether they are educated enough to handle a software. If they are not educated enough, then you will have to give them some training and all, right? So these are the main three feasibility studies that you have to do after gathering your requirements before going into design phase, right? So next is the design phase. We'll look into that. Okay, second is designing. The second step of system development lifecycle is designing the software according to the requirements you gathered in the first step, right? Now you have the requirements, you have an idea about the system, so now you are designing its structure. So among designing, there are four important things you have to do, right? First, you have to identify the software architecture. Identifying software architecture, what is that? Identifying what sort of software programs or software environment that your software is going to run, that the application you are going to develop is going to be used. Now let's say a person who is using a Windows computer cannot use a software developed for a Macintosh, right? So likewise, we have to identify the software architecture. Okay, are we developing the software for a Apple Mac or a Windows computer or an Android tablet, something? We have to identify the software architecture first. And second step, you have to identify the hardware components. Now let's say, take the previous example, if the customer is from a supermarket and they need a point of sales system for the cashier, then we have to identify the hardware components. Now for the cashier, we need a touch screen monitor to do those calculations, and we need a printer, a receipt printer, a barcode reader. We need a barcode reader. What else do you need? A money drawer. So like this, you have a lot of requirements, hardware components. So according to the user, according to the customer's requirements, you have to identify what hardware components are necessary for your system. And the third one is designing the structure and interfaces for your system. This is the most crucial part in developing a system. This is where these flowcharts, pseudocode, data flow diagrams, those things come into play. This is where you use those structure diagrams and all. And interfaces are very important. Interface is the part that a user interacts with the software, which means now whatever you see on the screen, the software, whatever you see on the screen is called the interface. The buttons, color, right, graphics, those things. So they should be attractive. The software should be attractive and easy to use. That is very important. Software should be easy to use. So that designing is done. And finally, we have to plan the test cases. Planning of test cases. Okay, now why do you have to plan test cases? Because although you develop the software, you have to test it, because there is a possibility of errors, because you are a human and you are the person developing the software. So there is a possibility of errors. Then you write some test cases. Test cases means, okay, how should I test the software? Okay, I have to test it over here. These things I have to test. These things I have to test. So you write up a set of test cases, and then you'll be testing it in the latter part. We'll discuss that. Right. So these are the main components coming under the designing phase of the system development life cycle. Right. Now that's it with the designing. Now the third step is implementation. We'll go to that. Coding. So implementation means you are just writing all those structures and diagrams that you developed in the designing phase. From your designing phase, whatever the structures were developed, you implement it using a computer language. You use a computer language. Now you might have learned the computer language in the previous lesson, programming languages. So you choose a particular programming language and start implementing or start coding the structures that you developed in the previous designing phase. So the coding part is done by software developers, right? So this part is where the software gets built. This is the building part, right? This is where you build the software. Okay, right. Now that is just the idea of implementation. And after coding, after building the software fully, you have to test it. The fourth step, testing. So this is number 4 on the system development lifecycle process. So each and every step is equally important. So testing, as it says, you have to test the software that you developed in your third step. In your third step, you developed or built the software. Now it is time to test it, whether it is working properly or not. So there are several methods of testing, right? First, there is this unit testing. Number 2, you have integration testing. 3, system testing. 4, acceptance testing. Among that you have alpha and beta testings. Right. Now, unit testing is like this. Now let's say from the previous example, right? Let's say the software is for a supermarket, right? For the supermarket. So in the supermarket, there will be a module, there will be a part for doing the sales in the cashier. There will be another part for doing the accounts, for performing the accounts. And there will be another part for calculating salaries and overtime values for the employees. So likewise, a software has a lot of small components, right? So as I told you earlier, a system is made up of many subsystems, subcomponents. So likewise, now in this supermarket system, let's say there are 3 components. One component is the sales, point of sales, right? It is the point of sales, and there is this accounting part, and finally you have salary management, right? Now these are the 3 components in your software, right, that you developed in the third step. Okay, now these are called units. Point of sales is one unit, accounting is another unit, salary management another unit. So unit testing means you are testing each and every module, each and every unit separately. Now you are testing point of sales separately, okay, doing all those accountings, so sales part separately, then accounting part separately, salary management part separately. Now this is unit testing. Next, integration testing. So integration testing means you are connecting 2 or more units together and then testing it, whether it's working or not. Now we have 3 units here. Let's say we are selecting point of sales and accounting, right? You are connecting both of these together and then you are testing that system, right? If there is no errors, then you go for this part. You are testing these 2 together, and then if they are working fine, then again you connect point of sales and management together, then you are testing it again. So likewise, you are connecting units together and see if they are working properly. That is integration testing. Now finally, system testing means all together, all of these units together, the whole system, big system, right? So you connect all those subsystems together and test the whole system, right? So that is system testing. Now, what is this acceptance testing? Acceptance testing, it is also called user acceptance testing, which means the alpha and beta, there are 2 groups. Now if it is alpha user acceptance testing, then these are users from the development organization. Now, the software company, the company who is developing the software for the supermarket. Now, if I am the person developing a software for the supermarket, I have a company. So there'll be a lot of users in my company. So I'm giving the developed software to those users. Okay, check whether it has any problem. Just run through those things, right? Run through the system and see if there is any errors. That is alpha testing. Alpha testing means giving it to the users, but the users will be from our organization or from our company. Beta testing means giving it to the public, giving the software to the public to test for errors, right? So better not give it to the customer for testing. Just beta testing means if you have a particular software that is not yet ready, if you are not sure that it is ready, you can give it to the public and ask them to use it for some time. If they find any errors, they can inform you, so you can fix the errors. As a compensation, you can as a gift, you can give something to them for the people who find the errors. So that is acceptance testing, testing the system with the real users, right? Okay. Now testing comes with another name, testing and debugging. What is a bug in a system? Bug, not a ladybug, right? Bug here means errors. In computer systems, a bug means errors, right? So debugging means fixing the errors. Debugging means fixing the errors. So while testing, if you find any errors, you debug them. While testing, if you find any bugs, you debug them, you fix them, right? That is the definition of debugging. Bugs means errors, debugging means fixing those bugs, right? Okay. So if you are satisfied with testing, if you are satisfied with your system, and if there is no any errors found, then you could go for deployment. Deployment is the step that you take when you are satisfied with testing. When you have tested the software and if you are satisfied, then you deploy the software, right? So in deployment, you have 4 methods of deployment. First you go with direct deployment. Then you have parallel deployment. Then you have pilot deployment. And finally, phased deployment. Phased deployment. Okay. So direct deployment means you have a existing manual system. Now you have a software. You totally just put aside the manual system. You totally eradicate the manual system and use the new computerized system. That is direct deployment. You're never touching the manual system. Manual system is put away. Get out. Right? You're putting the manual system away and you're using the computerized system. That is direct deployment. Parallel deployment means you're using both the systems, manual system and computerized system together. It's like when you are not sure how to use the system, or if you are facing some issues with using the new system. Now you might remember I said during the feasibility study, the operational feasibility, if people are having difficulties learning the new system, then they will go with parallel deployment. So they will use the manual system and also the computerized system until they learn the computerized system fully. After a particular time, they will put the manual system away, right? So running with both manual and computerized system is parallel deployment, going parallelly, right? And pilot deployment. Pilot deployment means, now if that particular supermarket has a lot of branches. Now take Cargill's. Now they have branches all around Sri Lanka. So the software was developed for a Kandy branch, for Kandy Cargill's supermarket. Software was developed. Now pilot deployment means first you're testing the software and you're implementing and deploying the software in Kandy. Then if it is successful, if you are satisfied with the software, then you go to another branch. You implement it in Colombo. Then if it is okay in Colombo, again you go to another city. Likewise, pilot deployment means testing in a particular area. You deploy it in a particular area and then slowly you move on, right? That is pilot deployment. And finally, phased deployment. Phased deployment means this is for people within a hurry. People in a hurry, like let's say, okay, a person comes to the software engineer and then says, okay, I have to open my supermarket within 2 months. I need a software. Now, how is this possible? A software within 2 months. They need a software within 2 months, but they need all the features for the supermarket. It is not possible practically. So we use phased deployment for this. What we do is, now earlier we discussed units or modules in software, parts, part by part. So what we do is, we design and develop the software in small parts and then deploy the necessary part first. Now in a supermarket, the point of sales part is very important. Point of sales part is necessary for the cashier, right? For the cashier, the software is very important. So we build that part first and then deploy it. We fix it and we install it on their computer and then say, okay, you use this for the moment. Now you are opening the supermarket soon, so we'll build you the cashier part first, so you can keep going while we do the other parts, while we build the other components. So likewise, phased deployment means you are developing the software in small parts and then deploying, right? Installing on the customer's computer part by part. First month you are fixing the cashier, second month accounting part, third month management, salary management. So then by the third month your whole system is complete. Then the development process is done. So that is phased deployment, right? Developing the software in small parts and then deploy, right? So these are the software deployment methods. Now, if you have deployed, if the customer has received the software, then finally you will have to go to the next step of maintaining the software, maintaining the product. Now in maintenance, there are mainly 3 things given for you. What are they? Finding and fixing new errors. Finding and fixing new errors. Number 2, adding new features, and finally taking regular backups. Right. Now, although the software is developed for a customer, although you have deployed it, still they might not have a full idea of how this software works, right? Sometimes they have a risk of losing the whole data, right? And they might come up with some other issues or some problems. Even they might find new errors that were not found during your testing phase. You have tested the software fine, but when the customer is using, sometimes they might get a new error. So you have to fix those errors for the customer in this maintenance phase. And sometimes the customer might call you and say, okay, I have this barcode reader in the cashier, but we need to fix some wireless barcode readers also. Can you do that for us, please? So yes, okay, you say fine, we'll add those things, and then you purchase some wireless barcode readers, and then you fix it with the existing system. So this also comes under maintenance. You are adding some new features to the system. And finally, taking regular backups. This is very important in maintenance phase. Maintenance backups, these are very important, because without backups, if you lose your data, the whole company will face a big problem, right? So sometimes the customer might not have an idea of taking backups, and they might forget, but you should not forget. As a software engineer, as a software analyst, as a business analyst, the developers or the engineers, they cannot forget their customers. So if you are maintaining their software, then you have to have regular backups. You have to take backups. Backups means taking a copy of the data used by the customer and storing for safety, because if that computer loses the data, if there is a virus or if there is a security issue and the data went off, the data got deleted, then we have to find. So that's where backup comes in. If you have copied the data to another source, if you are copying it to a pen drive, or if you are copying it to another hard disk and storing it away, then even if the customer loses their data, you will have a copy of their data. So you will give them, okay, we have the backup, don't worry. So that is coming under maintenance phase. So as this is the last step, we are done with the system development life cycle. So whatever we discussed up to now is about developing a software starting from the beginning to the end, right? So the next topic we have to discuss is about the software development structures. They are called models, software development models. So we'll be discussing it in the next video. So if you have any suggestions you want to tell me, then please drop it in the comments, and I would like to hear your feedback. So just place your comments below on the video so I can get an idea of what you need. Thank you, and we'll meet in the next video.